Section 6.1, angle measure. To convert between degrees and radians, the main thing you have to know is that 180 degrees is pi radians, which makes sense because if you think about the unit circle going halfway around, that'd be 180 degrees, which is pi on the unit circle. So to convert degrees to radians, you just multiply by pi over 180. Or to convert radians to degrees, you multiply by 180 over pi. So 60 degrees, convert that to radians. So we're going to take 60 degrees, convert degrees to radians. We're going to multiply by pi over 180. It's best to reduce first. So 60 and 180 can both be divided by 60. It goes on 3 times. So that's pi over 3. Similarly, we can convert pi over 6 radians to degrees. So start with pi over 6. But now we're going to multiply radians to degrees. So pi over 180. Or 180 over pi. So the pi's cancel out. And 18 divided by 6 would be 3, so there's a 0 on there, so it's 30. The best way to remember all of this is if you think about having degrees with the 180. If degrees is on top, you need degrees on bottom to cancel. And then if you have pi on top, you need pi on bottom to cancel. First off, let's talk about what standard position is. That's just when you have the vertex at the origin, and then one of the lines going on the positive x-axis, just like on the unit circle. And then the angle that it makes positive will be going up. Now we can talk about coterminal angles. Angles are coterminal if they're both in standard position and their sides coincide, so like they stop at the same place. So for degrees, 30 degrees will be the same as 390 degrees, because that would be a full circle plus 30. Or if you went around the other way, it would be the same as negative 330 degrees. Sketch that out real quick. 30 degrees would be about here. If you want negative 330, it would bring you back. Or if you want 390 degrees, it goes all the way around plus 30. It's very similar to what we did with radians already in the last chapter. To find the length of a circular arc, an arc is just a part of the circle, which means it's just going to be part of the circumference. And then how much of the circle it is determined by what the angle is. So there's a pretty simple formula. Since circumference is normally 2 pi times the radius, that'll be a full circle. 2 pi would also be a full circle in terms of radians, so we don't need to worry about doing any real conversion. It's just, by definition, radians tells us what portion of a circle it is. So the arc length is just radius times however many radians. So if this angle was pi over 3 radians, and the radius was 9, the length of the arc would be 9 times pi over 3, which is just 3 pi. Similarly, we could do the same thing for an area of a sector. The area of a sector is thinking about like a whole slice of the circle. It's the same idea since it's related to how much of the circle. You would just take the formula for area of a circle, which is pi r squared, but we're taking a portion of that, which is going to be however many radians out of the whole thing. Which would be however many radians out of the whole thing, which is 2 pi. And if you simplified this, pi would cancel, so it would be radians times radius squared over 2, which is radius squared times radians over 2 or times a half, same thing. So that's where the formula comes from. Let's keep those same numbers we had, 9 and pi over 3. So then our area of that sector would be 1/2 r squared, so 81, times pi over 3, which is 81 pi over 6, which is 27 pi over 2.